Exam 3, problem 6. And I apologize for the number of things I left out of this on the exam, like, well, messed up Avogadro's number, left out Boltzmann constant, left out the temperature, but here you go. Now that we have all of that correct, we have the molecular mass of hydrogen, we have the molecular mass of helium, we have Avogadro's number. We need to determine VRMS for both hydrogen atoms and helium atoms and average kinetic energy for both at 100 degrees C, right? All right, so where do we start? One, I'm going to start with what is the mass of hydrogen, right? And so hydrogen is 1.008 grams per mole, right? That's what the atomic mass is going to give us, divided by Avogadro's number, 6 times 10 to the minus 23, minus 20, 10 to the 23, right, per mole. All right, so mass of hydrogen is, let me just write in Avogadro's number since we'll need that more than once. Mass of hydrogen is 1.008 divided by, so 1.674 or 1.67 times 10 to the minus 24, 67 grams, which is 1.67 times 10 to the minus 24 times 10 to the minus 27 kilograms, right? Pardon me. All right, so now we want to get what is the mass of helium, all right? And so we're essentially looking at the same thing, grams per mole divided by 6.02 times 10 to the 23rd per mole. All right, so let's come over here and say we need 4.003 divided by Avogadro's number, so 6.65 times 10 to the minus 24 grams, right, is 6.65 times 10 to the minus 27 kilograms. All right, so that's the mass of an individual hydrogen atom, mass of individual helium atom, and now we need VRMS. So what's VRMS, right? VRMS is the square root of 3kT over m, right? Now, this T has to be in Kelvin. And so the temperature we need is not 100 degrees C, but the temperature we need is 373 Kelvin, right? 373 Kelvin. And we have the Boltzmann constant, all right? And we have the mass in kilograms, The reason we need the mass in kilograms is because in Boltzmann constant we have joules. We need kilograms to properly cancel out the kilograms in the joule. And so here we go. For part A, right? VRMS is square root of 3 times Boltzmann constant times the temperature, right, all divided by the mass okay. All right, so the Kelvin are going to cancel out. The joules per kilogram is going to conspire to give us meters squared per second squared. And so we're going to end up with meters per second at the end of the day. And let's set this up in Excel. All right, set this up in Excel. All right, we have, I'm going to put in the Boltzmann constant, 1.38 E minus 23. I'm going to put in the temperature, 373. And so we need the square root of 3 times the Boltzmann constant times the temperature divided by the mass of hydrogen. And we get 96 meters per second. Right? All right. Part B. Well, in part B, everything is the same except for the mass, right? So the mass is now 6.65. Just change that. 6.65, right? Times 10 to the minus 27 kilograms. So now we need to have the square root of 3 times the Boltzmann constant times the temperature of 373 divided by the mass of helium. And now we get 48 meters per second. 48 meters per second. Now, in part C, we're asked for the average kinetic energy. Right? And that is just 3/2 kT. All right? 3/2 kT. So, we'll pop over to Excel. Kinetic energy, 3/2 times K times T. All right? 7.72 times 10 to the minus 21 joules. 7.72 times 10 to the minus 21 joules is an average kinetic energy, right? And you'll notice mass is not involved at all. So for part D, the average kinetic energy of the hydrogen atoms, helium atoms, right? We get the exact same answer. Now, the point behind this is kinetic energy corresponds to temperature, right? So their kinetic energy should be the same. Why? Because they're at the same temperature. But because hydrogen is lighter, right? Because hydrogen is lighter and kinetic energy is 1/2 mv squared, the hydrogen atom has to be going faster than the helium atom in order for them to be going, in order for them to have the same kinetic energy. All right, that's it for problem 6. We're done with exam 3.